We will move on to existing assistive technology for blind and visually impaired people. This is a project in Toyota. You can imagine that why such a big company like Toyota want to do something about assistive technology, right? So yeah, if you want to work in US or something, I think this is the right topic you want to choose.
I don't think I'm different. I think how I interact with the world is I have no light perception, no colors, anything. I see everything pitch black. When I was sighted, I was this guy who didn't take no for an answer. When I lost my sight, I wanted to go back to who I was before. I have to plan ahead a lot. When I'm indoors, I'm trying to figure out where the doors are, where the elevators are. But inside a big building, I'm looking for the beep that tells me where the elevators are. I'm always decoding and investigating. Sounds, scents, landmarks, trying to figure out what things are. Being on Blade is fascinating. This has the ability to transform and change people's lives. Toyota's commitment is to develop a product that will actually improve mobility for the blind and visually impaired community. I think that mobility is really at the core of me being an independent blind man.
Hey, Bill, how are you? Hey, Roddy, nice to meet you. Can you grab my arm?
Using cameras, Blade can detect various features which are important to the blind community. Doorways, restroom signs, exit signs. In addition, we're also doing research on facial recognition type software. It'll scan the environment and tell you what you see. Wow, that's so neat. There's a restroom at 10 o'clock, there's a doorway at 12 o'clock. The second button on there, you would say, take me to the bathroom. And the device will guide you to the bathroom. What sparks me and really interests me is the ability to improve the mobility for as many people as possible. The ability to just get up and leave whenever you want to wherever you want would be awesome. Blade could change my life.
This device also tries to detect the text in the environment, the symbols, right? So to find the restroom and find the exit sign, right? And as Mr. Zhang just said, if you have a camera and you know where to aim the camera, the problem is pretty much solved, right? How about you have a camera and you want to find the exit sign in the environment? This becomes very challenging, okay? But this is a good start. We don't know how well this project is working right now, but yeah, we will see, or we can do something even better, okay? So this is one project I would like to share with you. And this is the second project. It's about tracing. For example, the tactile pass and the 导盲砖, right? And some of you may know that actually in Taiwan, we spent more than $1 billion before 2008. But after that, the policy has been changed. So the policy says that the tactile pass is not that useful for all the blind and visually impaired community. So we are not going to do it anymore. Then what's the alternative? So you can see like different kind of thing, maybe walk along the wall or some other different landmark, the features in the environment. You may feel that is this really possible? So if a blind person walk into an unknown environment, unfamiliar environment, this could become very challenging, right? And even we have a tactile path, the tactile path could lead blind people to anywhere, right? Maybe bump into the wall or end at nowhere, right? So that's more like the government need to think about to do a better plan for the environment instead of just leave it there and then say, oh, we are not going to do it, and you guys figure that out. And this is one project called Ariana. So this is a startup company in Italy. This is one of the idea about the tactile path, but the different thing is that the idea is to have just a cell phone and recognize the yellow and blue colors on the ground. That's the path. That's probably in Italian, but let me just explain this a little bit. So this company is actually funded by Andrea Bocelli's sister. And the idea is that you can see the yellow and blue line and the QR code there, right? The QR code could be one of the landmark. So you can imagine that the tactile path was replaced by the two color lines. And you can also see that at the intersection there is a QR code. So the QR code could be in front of ATM or an entrance. And I met him, he was in Taiwan like 3 months ago. And they come here to participate a startup event. Yeah. So I think the key technology here is you need a very robust color detector that can recognize the lines. And they also try to extend this project, for example, in a train station or the museum. Okay, so you can see that maybe in front of a painting, so they put a QR code in front of it so that a blind person can follow the path and see the QR code and know he is looking at maybe Mona Lisa. The lady there, her name is Laura. She's Andrea Bocelli's sister. This is a project, actually I just submitted to the conference. The project is actually trying to develop a device, work together with YCAN. So YCAN has been the most commonly used device and very useful in many environments, right? But we, as Mr. Zhang said, for example, in a crowded environment or in some different unfamiliar environment can become not that useful.
We enable a blind user to navigate through a complex indoor environment. The system helps the user avoid obstacles and navigate through narrow passing gaps. The system includes a depth camera, an embedded computer, a vibration belt for haptic feedback, and a refreshable braille display for scene descriptions. What can our system do to complement the white cane, the most common mobility aid in use today? A survey we conducted suggests that canes are helpful in tracing physical features of the environment, but less useful in identifying specific objects or avoiding contact in crowded environments. Walking a maze without touching the walls requires using the system for fine-grained navigation, similarly to crowded environments where one might wish to minimize cane contact. This visualization shows the onboard color and depth images displayed in relation to the user's orientation and position image. The 5 vibration motors are shown as red or blue dots behind the user, indicating vibration on or off. We tested how well the system could help the user find a target object, in this case an empty chair, in a space with distractor objects, in this case an occupied chair and a recycling bin. Using only the cane, the user moved quickly and confidently, sampling every obstacle before finding the correct target. Using only the system, the user moved more cautiously, but identified the correct target from farther away without guessing first. Using both the cane and system, the user again identified the target from a distance, but found the chair as quickly as with the cane alone. We also tested how well the system could help users navigate in some real-world environment. We had users follow the tactile paved path at Duckietown University, Taiwan, while trying not to contact pedestrians or experimenters with their canes. In some practice, they were able to detect people with the system before making contact with their cane. Here, a user navigates the hallways of our lab at MIT, Using only the system's haptic feedback, we test corners at a construction site and a bench below knee level, all before making physical contact. This work was inspired by the vision of the late Professor Seth Kelly. We're grateful to him for his leadership in this important field. We're also thankful for the help from Jordan Alsbach, Chi-Chi Chen, Yi-Wei Wang, Nicole Hernandez, Yu-Jing Lin, Paul Irvine, and Grace Day. This research was supported by the National Science Foundation, the Andrea Bocelli Foundation, the MIT Office of the Vice President for Research, and MOST Taiwan.
Okay, so again, so last time we talked about a self-driving car, and this week we talk about assistive technology. And one thing we need to think is that maybe some problem is too difficult to solve in 3 months, right? Then how can we formulate the right problem and then scale down the problem so that we can push it forward and later on scale it up?